Hi everyone! Today we'll be going over DeltaStream's latest feature, which we've named Applications. As we've shown in our other videos, DeltaStream exposes a SQL interface to define long-lived continuous queries to process real-time streaming data. It's typical for users to have a pipeline of real-time queries. This is where a sequence of queries processes and prepares data for the next query in the sequence, until you finally end up with the desired results at the end of the pipeline. These pipelines require multiple reads and writes against the streaming storage, as each query's intermediate result must be written back to the storage layer. However, in many cases, these intermediate results are not needed for anything other than feeding the next query in the pipeline. Also, each of these queries is running as a separate job with its own resources. And to address these inefficiencies, DeltaStream has come up with applications. An application is a bundle of SQL statements with optimizations to run more efficiently and cost-effectively. There are three main benefits to running applications. First, users can simplify their SQL queries by splitting complex computation logic into several smaller statements. This helps with readability and can help users debug their queries by isolating the processing steps. Second, applications optimizes reads and writes to the streaming stores. If multiple statements in an application have the same data source, the application will only read from the data source once, as opposed to reading for each statement. Also, virtual relations can be defined in an application for intermediate results. These virtual relations are not backed by any physical storage, and other queries in the application can read from or write to them without any I/O operations. Third, applications reduce the overall execution cost by running as a single runtime job. Packing several statements together allows for efficient resource sharing and lowers scheduling overhead for the shared resources. Also, the optimized I/O operations on streaming stores result in reduced network traffic, contributing to cost reduction. Let's go to DeltaStream and go over an example. If we navigate to the Stores tab, we can see that there are two Kafka stores already defined, one for US East and one for US West. These stores define the connection to individual Kafka clusters. In each of these stores, there is a topic called Page Views. In the US West store, there's also a topic called Users. Now, let's navigate to the streaming catalog, where we have already defined streams and changelogs. Clicking into our database and schema, we can see the relations defined for our use case. We have the stream Page Views East, which is backed by the Page Views topic in our US East Kafka store, and the stream Page Views West and changelog Users Log, which are backed by the US West Kafka store. Let's click on the Page Views West stream to see its details. Here you can see the schema of the data as well as other details, such as which store is backing the stream. The Page Views East stream is the exact same, but it is backed by the US East store. Let's also look at the Users Log. Here you can see the schema for this data, as well as the primary key which all changelogs have. Now let's head over to the SQL Editor tab to create our application. You'll be able to find all of the code below in the blog post linked in the description. To start the definition of an application, you write begin application, followed by the name of the application. In this case, it's Popular Pages app. All statements in the application are between the begin application and end application statements. Here you can see that we have 4 statements. The first statement is creating a virtual stream called Combined Page Views, and we're copying all the data from Page Views East into it. It's called Combined Page Views because the second statement is copying all the data from Page Views West into it. So the Combined Page Views virtual stream contains Page Views data from both US East and US West Kafka stores. The third statement reads from combined page views and joins it with the user's log changelog to create a new virtual stream called enriched page views. Finally, the fourth statement aggregates the data in the enriched page views virtual stream to find the pages that are popular. As you can see, we are filtering for women in California who have visited a particular page more than 2 times. Those results are written to the popular pages changelog. By using virtual streams for our intermediate results, the application doesn't persist these results back to Kafka. If we wanted these intermediate results to be written to Kafka, then we can simply define a regular stream instead of a virtual one. However, for this use case, we don't need these intermediate results for anything other than using it in another statement in this application. So we can save the network I/O and storage by using virtual streams instead. There are 2 other ways we could have solved this use case without using an application. The first is to simply run each of these statements as their own queries, and the second is to write a query using nesting. The first solution is not as efficient or cost-effective as running an application because of the extra Kafka topics involved to store, read, and write to intermediate results, and because each of the queries run as separate workloads, whereas an application runs as a single job and can better optimize the shared resources. The second solution of using a nested query can easily result in an overly complicated and long SQL statement that is hard to read, hard to understand, and hard to debug. As you can imagine, if we had used a use case with more complex data, deep nesting, or complicated logic, then writing queries with this approach can become overwhelming. Also, if users needed to materialize intermediate results, they would need to write multiple queries anyways, so nesting query wouldn't work for these cases. Alright, so we've run our application. If we navigate to the Queries tab, we can see that the application is running. Let's go back to the streaming catalog to see which new relations have been created. Note that the only new relation here is the popular pages changelog. The other 3 were the sources we began with. The virtual relations won't show up here because they only exist in the context of the application. Similarly, if we check out our store, we can list the topics and see that none of the intermediate topics for the virtual relations are created. We only see the new popular pages topic. Let's print this topic to see our final results. So that's it for this video. If you want to learn more about DeltaStream's new applications feature, a link to the blog post announcement will be in the description below. You can also find links to get in contact with us or sign up for a free trial.